So I thought for today that we can actually try something really weird um, that most people do when they start programming for the first time or when they start learning a new language for the first time. So the thing that you always do when you start programming for the first time is you write this hello world thing that is a tradition for a few reasons. And it's like your first accomplishment when it comes to a language or when it comes to programming sometimes in general. And I thought, okay, well, how do we do this? So I'm going to be doing this on this Windows Linux emulator or Linux for a few reasons I will explain later. But the point is, if I make in C and if I use nano, all I have to do is write, let's say, int main. And here I will say basically printf, the notorious printf that is slow. Hello world. And I'm going to put a new line in the end as well, right? Then because it's C, I have to say return 0. And obviously this does not work because we need to go up here and include our nice header. So if I save this now and I use GCC to compile it, and then I run it, which I get hello world. So obviously that works. But if I go back to nano and I completely delete this line and I save it and I compile it again, it doesn't work. So the interesting thing here is that, I mean, we are learning how to print hello world, but we're using a header. Like, what if we did not have to use a header? So if we go back to nano, header's gone, and this doesn't work anymore. So I'll just comment it out. So basically what hello world is it's a system call. Everything that usually is input or output like this is a system call, so a sys call. And there are a few ways for us to use such a system call. So basically a system call is made out of a few things. So it's basically made out of a output, input, and pretty much that's it. And we can have different types of system calls. So we can have write system calls, and we basically need to tell the system call what we need it to do. In our case, we wanted to basically do a standard out operation. So first we need to describe to it, well, the one thing that we do know is that we want a specific character sequence. So I'm going to say constant character well, it would be anything, right? So if I say A, here it would be hello world, same thing that we had before. Okay. Because I'm going to be using something called ASM, which is basically assembly instructions, almost. I'm actually going to make sure that this goes to a register. So I'm going to go here and I'm going to say register. And basically that will tell the compiler that it should put it to the register. It does not mean it's going to go to a register, but it basically tells it that I desire for that to happen. Though, because we want to write specific registers, what I'm going to be doing is I'm going to be saying, okay, well, there's a set of registers that we can write to, and they generally have different functionalities. Our hello world sequence or string, it doesn't matter, is going to be our second argument to our syscall, And for that reason, I'm going to use the register that's used for the second argument of a function. So that's going to be the RSI register. This is the name, not the register. And to choose the RSI register, I have to say ASM, like this, with 2 underscores. And in parentheses, I put double quotes and RSI. So now it's RSI hello world. So this is actually just very simply our string. So just to make this more clear, I'm going to put a comment here that says second argument to function and sure, address of string, because that's what it is, right? It's a pointer, so it's an address of the string. That's all we're passing to the register. Where is our data? Now we also need to know how big our data is, because obviously the system call doesn't know that. So we're going to do the same thing, say register, and here we're going to say int, and here we're writing to the third argument register, so the register that corresponds to the third argument of the function, which is the RDX. So I'm going to call this RDX basically. And same way as before, I'm saying ASM and RDX. And now that is going to equal 13, because that's how many, that's the length of our string, because I'm including the new line as well. Okay, so I'm going to make a comment that says third argument to function string length, so that we know what all of these things are as we're building them. So we have the most simple things. We have our string and we have the size of the string. So the next thing to do is to indicate what kind of operation are we performing. We're performing a file handle operation here, and we want to say that that's a std out operation. And I'm going to go above to do this. This is going to be the first argument to the function. We have 3 arguments, and this is the first. So it's going to be register again. And so basically, you can find online what number each functionality corresponds to. So for a file handle that's std out, in our case, it's just 1. So another operation might be 2 or 3. So you can find online what it is and just use it. So in our case, it's just an int that I'm going to call, and I'm going to use the register that corresponds to the first argument to a function, which is going to be the RDI register. And same way as before, I'm saying ASM. RDI. Cool. And I'm saying that's 1. And 1 corresponds to file handle standard out. So saying first argument to function, and I'm saying file handle standard out. Okay. Let's save this as well. So okay, we have our arguments for our eventual system call. The other thing that we have to do is we need a temporary register that will indicate the write operation to the system call. So basically, that's going to be the output of all of these are inputs. So these 3 are obviously basically inputs. They're the arguments. And we also need the output of that system call or syscall, which is going to be, in our case, something that indicates the write operation. So I'm going to go here and I'm going to say, let me delete this line, register, again, int, because again, it's going to be indicated by an int. You can find all of those online, which number corresponds to what operation. And for the write operation, we're going to use, first of all, the racks register. So I'm going to call it racks. And again, I'm using ASM. Racks. And I'm saying it's equal to 1, which basically means that I'm going to say it's a temporary register. And it indicates the write operation. And that's pretty much it. Okay, so now we have the components that we need for our syscall. So the question is, how do we perform that syscall? So the way you do this is, I'm going to start writing it. You use, again, the same keyword, the ASM keyword. I'm going to use volatile, which basically tells it not to optimize it, although if you delete it, it probably is going to do the same thing and work either way. But I'm going to write it. And now all I have to say is open the parentheses. So for basically a function to run like this, the first thing I need is the template of the function. And our template in our case is a syscall. So that's the template. So it basically describes what is the operation that we're performing. Now, underneath here, we're going to put our output. So the first thing that we put is our output. So we use a colon, and we use this notation to indicate the output. And we obviously, our output is our racks register. So we use the name of the variable, which is racks. And then we need to pass all of our arguments, and they will go all in this line. So it will be, well, first of all, this is an input. So our R here tells it that it's basically an input. So RDI, remember, is our first argument. Then we're saying comma, again, another input, which is going to be the second one, which is RSI, which is our string. And then the last input, which is the length of the string, which is RDX. And that's what we want from this. And then the last thing that we need, so the last part of this is something called clubbers. And basically here we can basically tell the compiler to never write to these locations. So if I want to save something to a register, I can say, or I want to use a register again, for example, I don't want anything written to it. No matter what, I will write that here. So for example, I would write memory. So I could just literally write memory here. In our case, I found that it works even if you don't write anything here. So you could just leave this empty. And just to describe this a little bit better, I'm going to go here and I'm going to say that's our output. This is our input. And this is the template. And here we have our clubbers. And back here, we can go to GCC source.c, compile it. It works, which is good. And then we can just run it, see what happens. And it says hello world. And it uses no headers. So again, if we go to Nano, we're not using any headers. We're not using printf. We're just doing everything manually. Now, why would you ever do this? You should never do this probably, but it's an interesting study as to printf in general is known as a function that is slow and should not be used much for a variety of reasons. And it's kind of interesting to see how it works actually and what may be causing that. So, and actually to see how, this is not obviously assembly. You can actually turn this completely to assembly, but this is the simplest. We might do this at some point. And this is the simple way of doing it, the simpler way to do this. And it's a bit more fun than just doing this with assembly, because there's going to be a few more instructions, especially move instructions. So yeah, now you can printf without printf, as long as you get the size right. Yeah, great. So that was pretty much it. Keep in mind that you have to use GCC for this, probably. You would not be able to do this if you manage to compile this in Windows with most, I think, compilers, because it does not like the ASM keyword. So just try this out either here, or if you try it in a compiler online, like you find a C compiler online, it should work there as well, because they use GCC. So if you can't do it on your computer or whatever, you can just go to any free compiler online and it should work just fine. Okay, so I hope that was cool to you as much as it was to me. See you in the next one.